We shall now try this problem 53 of your text. It says that the says that uh, a bob of a pendulum at rest. So let us first draw, because I have already drawn this circle for you. Just drawing a free hand circle is rather difficult. This is the bob of a pendulum. Is at rest, right? Now it is given a sharp hit to impart a horizontal force of root 10 GL. That means sharp force is given here so that it has a velocity, let's say velocity V0 is equal to root under root 10 GL. Its velocity is under 10 GL. That's all that is given. Where L is the length of the pendulum. So this is the length of the pendulum. Now find the, what is to be found? You have to find the tension in the string when three situations. The string is horizontal. So let us take this first situation first. Here, the string is horizontal. That means the pendulum has swung in this direction and it has become horizontal. Now, in any pendulum problem, I wanted to tell you one thing. How far the pendulum will rise? Will it really go up to the horizontal point? Depends upon what is the energy given to this pendulum. So it is always, you may need to check how far it will rise. Whether it will rise up to horizontal at all or not. But since paper setter has said the string is horizontal, let us consider it will go to horizontal. It goes to horizontal. Now let us also see what is, if this is the way zero, what is the initial kinetic energy? Kinetic energy of the ball is half m square. Half m zero square. This is equal to half m, and V0 is given root 10 GL. So this is into 10 GL. This is equal to 5 mgl. 5 mg. This is a very important parameter that we shall need all throughout this problem sum, because this is the initial kinetic energy of the ball. So wherever it goes, it cannot cross this much of energy level. This energy level, its energy is 5G. Now let us go to part A. Let us go to part A. Part A of the problem, when horizontal. Horizontal. When it is horizontal, and it goes from here to here, the work done, or its increase in potential energy is mgl. So gain, I write gain potential energy is equal to, here you can cross check. To come to horizontal level, it needs to gain a potential energy of mgl, and it had an initial kinetic energy of 5 mgl. So definitely it will come to horizontal level because it needs much less energy. So when it reaches horizontal, when it is horizontal level, uh, residue kinetic energy that will be left with it, residue kinetic energy is I mgl minus mgl is equal to 4. And this kinetic energy of 4gl, how will it manifest? It will manifest as the tangential velocity of this ball, right? Let us say its tangential velocity at this point is v1. Say its tangential velocity, then what is the tangential velocity is v1, then its kinetic energy is half mv1 square. So kinetic energy is equal to half mv1 square. And this kinetic energy, half mv1 square, is equivalent to its energy 4gl. Therefore, we can write here, so we write here half m v1 square is equal to L equal to 4gl. From there, we get v1 square 8 multiplied by 4 is 8. So 8gl. So this is its kinetic energy. So v1 square, we have found v1 square is for 8gl. And they want us to find out the tension of the string. Tension of the string is equal to the centripetal force. So the centripetal force is equal to the centripetal force equation is mv square by r. R is the radius of the circle. Here it is mv square by L. And instead of v square, we write v1 square. Okay, let me do it a little more carefully. mv1 square. mv1 square by L. So this is equal to m by L multiplied by v1 square. You have already got 8gl. 8. So this 8 and L gets cancelled. This is equal to 8 mg. So this is one answer. Tension of the string, which is equal to the centripetal force, is equal to 8 mg when the body is horizontal. Now let us see when the body is, when the body reaches the highest point, that means the body reaches here. The body reaches here. As I said at the very beginning, we still do not know whether it will reach to the highest point. We still do not know that, whether it will reach to the highest point. Let us see how much energy it reaches to the highest point. Question number B. If it has to reach to the highest point, to come to horizontal point, it needed a potential energy of mgl. And to come to the highest point, it needs a potential energy of mg into 2l. So potential energy or needed highest point is equal to 2 mgl. And it is much higher than initial energy 5. It is much lower than the initial energy 5 mgl. So we are sure that it will reach the highest. Once it has reached the highest point, then what is the energy left? Then left out energy 5gl minus 2gl equal to 3gl. This 3gl in a very similar way, like we have done here, gl will produce the tangential force, tangential velocity. Once again, tangential, if the velocity at this point is v2, if the velocity at this point is v2, then half m is equal to 3gl, 3. There was a m here. This was 5 mgl. This, excuse me, this was a 5 mgl. This was a 2 mgl. So this is 3 mgl. So 3 L. This is equal to 3 mgl. From here, we find that V2 square, m gets cancelled. V2 square is 6gl. We get V2 square is equal to 6L. Now, mind it, when the body was here, its downward force mg was working in this direction and tension T was in this direction. They were rectangular to each other. So, we straight out calculated that centripetal force is equal to mv square by equal to the energy mv square by L, right? But here it is not so. Here, this is the tension. Also, in this direction, the force mg works. And centripetal force is, of course, always oriented to the center of the circle. Therefore, here, tension T plus mg, both together provides the centripetal force mv square by L. Therefore, tension T is equal to mv2 square, because we have considered is v2 here, mv2 square by L minus mg is equal to mv2 square. V2 square is 6gl. So m by L v2 square, m by L v2 square is 6gl minus mg. Here, this L and this L gets cancelled. So you have 6gl, 6mg minus mg. That is equal to 5mg. Second answer. There is a third part of the question for which I need a little space here. Third part of the question is, now this is fine. Third part of the question is, when the string is at 60-degree angle, when the string is at 60-degree angle, right? That means this is the third part of the question where the string is at 60-degree angle. A little shifted. Anyway, let's not distort this, then it will be uh, very cumbersome. Third part is when the bob is at 60-degree angle with the upward vertical. That means if this is the upward vertical, this angle is 60 degree. Now, once again, there will be a question, will it reach this point at all? But already you have found that it reaches the highest point. So obviously it will reach this 60-degree point also. There is no doubt. And we'll go in the same fashion. We go in the same fashion. Here we draw a boundary line of the board and we go to evaluate the third question. At this point C, similarly, we calculate how much is the potential energy required. That means what is the height from here to here? We know this is L plus this is L sine 30. If this is 60, this is 30. Right? So, let us consider this point as, say, A. We need to give a name to make it easy to understand. At A, at the point A, the gain in potential energy is equal to mg. This height is, from here to here, this height is L plus L sine 30. Sine 30 is equal to half, we know. This is equal to mg L plus half L. So it is mg L multiplied by 3 by 2. We write rather this way, 3 mg L by 2. This is the potential energy. Now, initially, it had an energy 5 mg. Look, the three part of this problem is same. So when it reaches the point A, the kinetic energy will be 5 mgl. I am making this mistake repeatedly. Will be equal to 5 mgl minus this energy minus 3 mgl by 2. This is equal to 7 by 2 mgl. So it's, if this velocity at this point is v3, if this velocity at this point is v2, say. So we have already considered v2, so they say velocity at this point is v3. If velocity at this point is v3, then in the same fashion, half m v3 square is equal to 7 by 2 mgl. From this, you can find out, v3 square is equal to 7 gl. V3 square is 7G. I shall take a little bit more space. That's right. So V3 square is 7GL. We have got. In the similar fashion, so centripetal force here at this time, centripetal force is equal to, we know, half, sorry, centripetal force is mv square by r. Centripetal force is m v3 by radius r here is l, mv3 square by l. So this force, centripetal mv3 square by l, so this is m by l. And what is v3 square? 7gl. 7g 7gl. So L and L gets cancelled. So we are left with 7mg. Now look at this diagram once again. I'll bring the diagram a little bit down. Here, the force mg, or rather I do one thing. I draw the diagram once again here. At this point, this is the center, this is the length L, and at this point, this is the downward force is mg, and the component of mg which is working in this direction is mg cos of 60, mg cos of 60, right? So in this case, centripetal force is 7 mg. So, and also there is a tension in the string. So in this case, tension in the string T plus the component of the mg force, mg cos 60. This is equal to the centripetal force 7mg. From here we find tension is equal to 7mg minus mg, and cos 60 is 0.5. This is equal to 6.5. So when the bob of the pendulum is at 60 degrees with the vertical, its tension is 6.5 mg. When the bob of the pendulum is the topmost point, its tension is 5 mg, and when it is horizontal, its tension is 8 mg. So this is how you solve this problem. Next problem we shall see in a few minutes.